All right, let's find the instantaneous rate of change if we're looking at the function f of x is equal to the square root of 2x plus 1. The category of functions like this are called radical functions. And that's anytime you have a fractional root or a fractional exponent. This particular one is a square root function. To find its domain, we want to set, so the domain of f, we want to set the stuff under the root symbol equal to 0, or pardon me, greater than equal to 0, and then solve for x. And we want it greater than or equal to 0 because square roots, any even root, fourth root, sixth root, has to be at least 0 or positive. Well, this function, we have f of x is equal to the square root of 2x plus 1. So the stuff under the root symbol, that's just 2x plus 1. And we want to set that greater than or equal to 0. And then we're going to solve it in much the same way that we solve equations. The only thing we have to be super careful of is if we multiply or divide by a negative number, then the direction of the inequality flips. But it's good that we're not going to do that. So we want to subtract 1 from both sides. That gives us 2x is greater than or equal to negative 1. And then we want to divide by the coefficient of x. But it's really just much better to think of multiplying by the reciprocal. So we're going to multiply the left term by the reciprocal of the coefficient of x and the right term. And I see that this number I'm multiplying by is positive, so I'm groovy. I don't have to worry about weird signs. 1/2 times 2 is 1, so we just get 1x on the left. X is greater than or equal to negative 1 times 1/2 is negative 1/2. That means that this, let's see, yeah, the smallest that x can be is negative 1/2, and then it can go all the way positive. So we would write the domain of f. It can get as large as we want because think of plugging large numbers in for x, we're going to get positive outcomes. But the smallest number that we can plug in for x is negative 1/2. If we plug in negative 1/2, that's 2 times negative 1/2, that's negative 1 plus 1 is 0. F of 0 is 0. So, pardon me, f of negative 1/2 is 0. So the range of f the smallest is going to be 0, and it's going to go to infinity. The shape in general of a rational function, radical function, is like a sideways, half of a sideways parabola. And ours will start at -1/2. And let's see, if I let x be 0, 2 times 0 is 0, plus 1 is 1, square root of 1 is 1. That's the point 0, 1. We're starting at -1/2, 0. And we can get one more nice point. If I plug in let's see, because the next nice number would be 4. That doesn't give me, I mean, the square root of 4 is nice, but that doesn't give me a nice x. But then 9, if I want this whole thing to be 9, I would want to plug in 4 for x. So f of 4, that's the square root 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. So we get the point 4 comma 3. 4, 3. And there's our function. And I'm going to look at it on the pretty graph. SQRT brings up the square root symbol, and I want 2x plus 1. I don't want that anymore. So it does indeed look like what we said. So f of 4 is indeed 3. And I don't know why it's doing that. 1, 1. Okay, prettier. And the point that we wanted to consider was 6, no, 0, f of 0. Okay, good. So we have f of x is the square root of 2x plus 1. Then we have f of 0 and f of 0 plus h. And these are nicely easy. 2 times 0 plus 1 is just 1, and that square root of 1 is 1. And 2 times 0 plus h plus 1. So I can distribute 2 times 0 is 0, 2 times h is 2h, so 2h plus 1. Those are the two function values that we'll plug in. So we are finding the instantaneous rate of change at the point, we said that at 1 we got 1, at the point 1, 1 is the limit as h goes to 0, f of 0 plus h minus f of 0 over h. That's the limit as h goes to 0. For the second one, for f of 0 plus h, we got square root of 2h plus 1 minus, and f of 0 was 1, all divided by h. Anytime you have a square root in a fraction and you want to simplify that fraction, we want to multiply by the conjugate. And remember, the conjugate, if we have A plus B, the conjugate is A minus B. And if we had A minus B, the conjugate would be A plus B. So it's the same first term, the same second term, but the different sign in the middle. So we want to multiply numerator and denominator of this big fraction by square root 2h plus 1 plus 1. So same first term, same second term, but different sign in the middle. And the same thing with the denominator, 2h plus 1 plus 1. And now, again, we're going to distribute. We're going to find the product of the numerator and simplify, but we are not going to distribute or simplify the denominator. And we're not going to multiply out the numerators step by step, because we know that we had here a minus b. If we multiplied by the conjugate, always we get a squared minus b squared. First term squared, minus sign, second term squared. And that's why we like this, because when we multiply by the conjugate, each original term is squared, so square root squared goes away, and there's no middle term. Okay, so we've got the limit as h goes to 0. Our first term is the square root of 2h plus 1. So I have 2h plus 1 squared minus, and the second term is 1 squared. And then in the denominator, we're just going to leave 2h plus 1 plus 1. And now this is very happy. We have the limit as h goes to 0. Square root squared, we're just left with what's inside. So 2h plus 1. 1 squared is 1, so minus 1, all divided by h times the square root of 2h plus 1 plus 1. In the numerator, the ones add away. We're just left with 2h in the numerator. Okay, and the denominator is h times the square root of 2h plus 1 plus 1. Yay, the h's divide out. Now we have the limit as h goes to 0 of 2 over, let's see, 2h plus 1 plus 1. Is that right? And we are now going to let h be 0, because I can let h be 0 and have a defined fraction. Let's do pink this time. So we have the limit as h goes to, oh no, we have 2 over the square root of 2 something plus 1 plus 1. And that something is 0. 2 times 0 is 0, plus 1 is 1. Square root of 1 is 1. So that gives us 2 over 1 plus 1. 2 over 2 is 1. So the slope of the tangent line at the point 1 comma 1 is 1. Let's look at the pretty graph and see if we can see that. So our point is 1 comma, oops, our point is 0 comma 1. And it does look like at 0, 1, the slope of a line that touches the graph would have a slope. It's a positive slope and it looks like it'd be 1. So let's find it. Let's let m equal 1. And we said that xy was 0, 1. So we have, here we go. We have y equals mx plus b, and we're solving for b. Y is 1. M is 1. X is 0. Oh, that should have been blue. That much. And then plus b. 1 times 0 is 0. So we get that 1 is equal to b. Is 1 the y-intercept? I want everybody to yell. No! 0, 1 is the y-intercept, because an intercept is a point, not a number. Okay, so our line will be y is equal to, we said the slope was 1, so x plus 1. Let's graph that line on the pretty graph. Nice. So our slope, I can see it now, up 1 over 1, up 1 over 1. So we do indeed have a slope of 1 for our tangent line at the point 0, 1. Now, let's do the ultimate fun one. Let's find the instantaneous rate of change at the point AF of A for f of x is equal to 2x plus 1. So we need f of A and f of A plus h. Okay, f of A, we just substitute in an A, and we get 2a plus 1. When we substitute in A plus h, we just get 2a. I'm going to distribute this to times 2h plus 1. So the two functions I'm going to plug in are f of a is the square root of 2a plus 1, and f of a plus h is the square root of 2a plus 2h plus 1. Great. The instantaneous rate of change at the point a f of a is the limit as h goes to 0 and let's see, first, let's plug in let's write it this way. So we have f of a plus h minus f of a. So we get that the limit as h goes to 0 f of a plus h is the square root of 2a plus 2h plus 1, and f of a is the square root of 2a plus 1. And now I see that I've got a, well, first term minus second term. The conjugate will be first term plus second term. So we're going to multiply. Let's scooch this over. We're going to multiply numerator and denominator of that. So equals the limit as h goes to 0 2a plus 2h plus 1 minus 2a plus 1. First terms, let's, here we go. This is so fun. Okay, we've got the same first term, the same second term when we write the conjugate. So 2a plus 2h plus 1, 2a plus 2h plus 1, and the sign in the middle is the opposite sign. So here's a negative, I want a positive. The second term is going to be square root of 2a plus 1. Great. Now, in the denominator, we are not going to distribute. We want to keep h as a factor. So let's write this. The limit as h goes to 0. In the numerator, I know that a plus b minus a minus b is a squared minus b squared. So I'm going to square the first, square the second with a negative sign in the middle. So we squared the first term, minus sign, squared the second term, and then divide this whole thing by h times the sum of the two terms. Square root of 2a plus 2h plus 1 plus, because of the plus sign, the square root of 2a plus 1. Beautiful. We have the limit as h goes to 0. When we square a square root, we're just left with what's under the root. So we have 2a plus 2h plus 1 minus, and the same with the second term. We have 2a plus 1. And I have to be very careful to remember to keep parentheses around the 2a plus 1. And in the denominator, we still have h times the square root of 2a plus 2h plus 1 plus the square root of 2a plus 1. The denominator has not changed. Now, I know that it's just going to drive y'all batty, but I want to take one extra step and remove the parentheses in the numerator and then strike out common terms. You don't have to show this step. So we have the limit as h goes to 0 of 2a plus 2h plus 1. Negative 1 times 2a is negative 2a. Negative 1 times 1 is negative 1. And this whole thing is divided by h. We haven't changed the denominator, so it still looks weird. 2a plus 2h plus 1 plus the square root of 2a plus 1.